Assalamualaikum and hi, my name is Nurul Izzati binti Muhammad. My matrix number is 207001. So, as we can see, the given circuit is a parallel RLC circuit, and since there is an application of current source, we are going to see the step response of a parallel RLC circuit. What I understand about this circuit is that initially this switch is closed, and the current source will flow through this wire over here in a closed circuit. And then when t equal to 0, the switch will be open and the current source will flow through the capacitor, the inductor, and the resistor. After a long time, this current source will only flow through inductor, and the inductor at that time will only act as a piece of wire. And once again, the current source will flow through in a closed circuit by flowing through the inductor. So it means that during that time, the value of IL will be equivalent to the value of IS. And also the value of voltage at that time will be equivalent to 0. Okay, so now I will construct the circuit component. Okay, DC current, the switch, capacitor, inductor, resistor, and ground. Okay, so to insert the value of current source, double click at this value and then just type in the value that we want. So here is 24 milliamps. True, right? 25 nanofarad, 25 millihenry, and for the first, we are going to see the output when the value of resistor is equal to 625 ohms. Okay, and then just connect all the components. Okay, so next, place the current clamp. Place the current clamp at the inductor and also the oscilloscope. Okay, so then connect the current clamp to the positive channel A, and then for the negative channel A of the oscilloscope, connect it to the ground. Okay, so initially the switch is closed. You can delete this. Okay, so now we observe the output when the value of resistor is equal to 625. So run, open the switch and stop the simulation. Then adjust the circuit. Okay. So how to read the current using oscilloscope, because we know the oscilloscope shows the value for voltage. So how to read current is that if we can see our current clamp here, it is right. It says that it is 1 volt per milliamps. So it means that when, for example, if you can see here, okay, I'm using the first here. Okay, so initially the voltage here, it state 12 volt, right? So it means that at this time the current is equal to 12 milliamps, because this is our ratio of voltage to current. Okay, so initially we can see that the current is equal to 12 milliamps, and then when the switch is open, it will gradually increase, okay, to its steady state, or the final current, which is, we can see, is 24 milliamps. However, we can see that at some point it overshoot the value of steady state, or the final current, which it is over 24 volt. Okay, so just to keep that in mind. So next, if we change the value of our resistor to 500, okay, switch off the switch. So switch stop simulation. Okay, So now we can see that, okay, so now we can see that initially the voltage is equal to the current is equal to 12 milliamps, and then when the switch is open, it will gradually increase to its steady state of current, which is equal to 24 milliamps. However, unlike the before circuit, when we use the value of resistor equal to 500, it never overshoot the value of steady state current. Okay, so yeah, and then we're going to observe the output when the value of resistor is equal to 400. Sorry. So switch off close the switch, and then start, open, stop. Okay. So if you can see here, initially the value of voltage is equal to 12 volt. The value of current also is equal to 12 milliamps. Okay, and then when the switch is open, so when the switch is open, it will gradually increase to its steady state or the final current, which is 24 milliamps. Okay, after a long time. And the same when we see the value of resistance is equal to 500, we can see that when it is increasing, it never overshoot the value of current steady state. Okay, it never overshoot it. Okay, so now I will show the calculation to verify our output just now. So when the value of resistor is equal to 625 ohm, when we calculate the alpha and the omega node, we can see that the value of alpha is less than omega node, which means that at this time this circuit is underdamped. Okay, so when we calculate it, we will get this expression for IF, and then when we calculate the value of alpha and omega node for R equal to 500 ohms, we can see that the value of alpha is equivalent to omega node, which means that at this time this circuit is critically damped, and after we solve all the initial conditions and simultaneous equation, this is the equation that we gain. Okay, so lastly, when the resistor is equal to 400 ohms, and we calculate the omega node and alpha, we can see that the value of alpha is greater than omega node, and at this time, the circuit is overdamped. And after solving all that, we are going to get this expression. So that's all from me. Thank you.